Hello everyone, I am Sakshi Phatak from Bharatiya Vidyapeeth's College of Engineering for Women, Pune. I am currently studying in final year of computer engineering. I am going to show you how to create a very interesting project based on natural language processing. The title of the project is Text Emotion Detection. So let us first see the project description. Emotions are expressed through words, gestures, expressions. And with the ease of accessibility of social media today, emotions can now also be expressed through tweets and Instagram or WhatsApp stories. So here I have built a web application for text emotion detection or text emotion classification using Streamlit and Python. In this project, we will be taking text as an input and classifying that text into emotions like joy, sadness, fear, neutral, anger, shame, etc. using natural language processing. So now you might have a question, what is natural language processing? So let us see what is natural language processing. Natural language processing refers to the branch of computer science or artificial intelligence in which computers are given the ability to understand text and spoken words in much the same way as human beings can. In short, using natural language processing, computers can understand speech and written text like human beings. So it is a way in which we can communicate with the machines. One of the many applications of NLP, emotion detection in text, is the one. Before moving ahead, I'll show you how our project looks like or what is the output of our project. So here, this web app is created in which you can user can enter text here, any text here like I am happy. After entering the text in this text box here, you can click on the submit button. Now you can see the emotion of your text entered. So the original text was I am happy. The prediction here is joy. That means the text, the feeling or the emotion in the text is joy. And the confidence here indicates the probability of that emotion, which is 0.7653. And in the second part here, prediction probability graph is plotted in which you can see joy has the highest probability. That means our text is in the emotion joy. Now let's move ahead. So let's begin the most important part or implementation of the project. So first I would like to tell you about the data science project lifecycle. A data science project lifecycle includes multiple steps. First step is data collection. Data is a major aspect of any data science project which we will be building. So initially the data needs to be collected from various resources for training our model. The second step is data preparation. As data is collected from various sources, it may contain some noise or other unwanted stuff. So before applying our model or applying our algorithm, we need to clean the data and prepare it for training. So this is done in the second step, data preparation step. Third is feature engineering. Not all features are useful for our prediction. So selecting the important ones, extracting and selection of features is done in this step. Next is training and testing the model. So the model is trained and the performance of the model is evaluated by testing the model. Last step is model deployment, in which we will deploy our model as a user interface. So in this project, I have used Jupyter Notebook for training the model and PyCharm for writing the deployment code. First, we'll see what data we have used here. As we have seen, data is the most prominent part of any data science project. So let us first see what dataset I have used in this project. So we will use a dataset that contains various text with different emotion labels. The dataset has 8 emotions: joy, sadness, fear, anger, surprise, neutral, disgust, and shame. So this dataset will be used during the training phase. So in the next slide, I have shown you a snip of our CSV file which we have used in the project. So as you can see, there are two columns in our dataset. First is the emotion column, second is the text column. The emotion column gives the emotions in our dataset, and the text column gives the text for which we have to predict the emotion. Now let us see our Jupyter file. So I have created this Jupyter notebook first, named as text emotion detection. First, I have imported three prominent libraries which are used in almost every machine learning project. So let us study about these libraries in brief. First library imported is Pandas. So Pandas is a software library written for the Python programming language for data manipulation and analysis. Second is NumPy. NumPy itself stands for numerical Python. So it is a library for Python programming language, adding support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. Third library which we have imported here is Seaborn. So Seaborn is a library that uses Matplotlib underneath to plot graphs. It will be used to visualize random distribution. Let us go back to the code. So after importing the library, the next step which we have followed is loading the dataset. So we need to load the dataset first in order to train our model. So emotion dataset.csv is the dataset used here, which we have studied earlier. Now, first we have created a data frame df in which, using the pd.readcsv function, we have loaded our CSV file. Next, df.head function is used to display the first 5 rows of our dataset. So here you can see the first 5 rows of our emotion dataset. Now, in our emotion dataset, we'll see how much count of each emotion is. So using value counts function for the emotions column, for this column, we'll count the number of occurrences of each emotions. So here joy is 11,045 times. Similarly, sadness, fear, anger, and other emotions values are counted. Next, using the Seaborn library, we have plotted a graph keeping emotion as the X label and count of the emotion as Y label. So in this graph, you can see that joy emotion has the highest count and shame has the lowest count in our dataset. Next step is data pre-processing. So as I have told you that raw data cannot be used directly to train our model. It first needs to be pre-processed and cleaned. So data pre-processing is a very prominent step here. Now you can see I have imported neat text library. So what is neat text library? Let us see. Neat text is a simple natural language processing package for cleaning text data and pre-processing text data. It can be used to clean sentences, extract emails, phone numbers, web links, and emojis from sentences. It can also be used to set up text pre-processing pipelines. This library is intended to solve the following problems. The first is cleaning unstructured text data. Second is reducing noise in the text. Third, avoiding repetition of the same code for pre-processing. So it is a library used for cleaning the text data. It is a very important library in natural language processing package. To install the neat text library, you can run this command in your Jupyter notebook. Exclamation pip install neat text. Now we have imported functions from the neat text library as NFX. So first step here we have performed is removing the user handles. So what are user handles? When you collect data from social media websites, there are some user handles like Twitter handles or Facebook IDs are there. So for cleaning the data, we will use the function here. So first we have created a column clean text in our dataset, and in that column we will be adding the cleaned or processed text. So our original or raw text is here, and we have applied nfx.remove user handles function on it. So remove user handles function will remove the user handles in our text, and the processed text will be stored in this column. Now if you want to view the functions in this library, neat text library, you can write this command dir nfx. Using this command, you can see that we have a list of variety of functions available in this neat text library. You can see there are functions like extract currencies, extract hashtags, extract phone numbers, removing currency symbols, removing hashtags. So all these functions are for text pre-processing and text cleaning. So neat text library is a very useful library. Next step here we have removed the stop words. So stop words are the words which are frequently used or which have no impact in our prediction, like and, articles like the, and, verbs like is, has, etc. So we need to remove these stop words from our text. So using the nfx.remove stop words function, we have removed the stop words in our text. Now we have displayed our dataset here. So now our dataset contains three columns. First is the emotion. Second is the text which contains the raw text or unprocessed text. Third column here is clean text which contains pre-processed or clean text here. Now we need to split the data into input variables and target variables. So what are input and target variables? As you know, dataset contains variety of features and attributes. And most prominent features are extracted from the dataset, which are used for training the model, which is used as the input to train our model. So these input variables are stored in X, and Y denotes target variables, that is labels or the output which we get after our prediction. These are target variables. So here in our project, X will store the column df clean text. That is, this will be the input for training our model, and Y, that is target variable, will be emotion. So we need to predict the emotion of our text, right? So Y will contain the emotion column. Now we'll split the data into train and test set. Now for training the model, we cannot use the entire dataset. We need to split it into train and test dataset. So model will run from the train dataset, and we will use the test dataset to evaluate the model's performance and measure the model's knowledge capability. So, new library used here is sklearn. First, we'll learn what is the library sklearn. So, scikit-learn or sklearn library is the most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction via a consistent interface in Python. This library, which is largely written in Python, is built upon NumPy, SciPy, and Matplotlib. So basically, a scalar library consists of various models and algorithms which can be used for training our model. So from sklearn model selection, we have imported the train test split model. So train test split model will split our dataset into two datasets, which is first is training dataset and second is test dataset. Now we have created variables xtrain, xtest, ytrain, ytest, and we have split the x and y data into training and testing dataset. So the test size is 0.3 here. That means in 100% data, 30% of data will be used for testing our model and 70% will be used for training our model. Now, here comes the most important step of any machine learning project, which is training the model. So what is training the model and what are the concepts used here? We'll be looking it further. So, pipeline is used here, count vectorizer is used, SVC, random forest classifier, logistic regression. These three algorithms are used. Let us study about these concepts here. So training the model. It is a process which involves providing a machine learning algorithm with training data which the model will learn from. So first concept we need to learn here is pipeline. So what is a pipeline? To make the process of training our model faster and automated, we will use a machine learning pipeline. Machine learning pipelines automate the machine learning workflows such as model fitting and training. Doing so saves the developer's time and reduces model errors. Machine learning pipeline is a new approach adopted by many developers as it produces quality models which are free from bugs. Next concept we learn here is count vectorizer. So count vectorizer is a great tool provided by scikit-learn library in Python. It is used to transform given text into a vector on the basis of frequency of each word that occurs in the entire text, which machines can easily understand. This is helpful when we have multiple such text and we wish to convert each word in each text into vectors. So as you know, machines cannot understand human language or text. So we need to first convert it into numerical format. So count vectorizer here can be used to convert such raw text into vector format. Next, we will study about the algorithms we have used in this project. In this project, I have used three algorithms. I have compared these three algorithms and used the best uh, algorithm for training our model. So we'll first learn about this algorithm. First is the support vector machine. SVM is a supervised machine learning algorithm that is used in many classification and regression platforms problems. It still presents as one of the most used robust prediction methods that can be applied to many use cases involving classification. It works by finding an optimal separation line called a hyperplane to accurately separate two or more different classes. The goal is to find the optimal hyperplane separation through training the linearly separable data with the SVM algorithm. Second algorithm used is random forest classifier. Random forest is basically the combination of multiple individual decision trees to act as an ensemble. Ensemble learning can be defined as a paradigm where multiple learners are trained to solve the same problem. When it comes to classification using random forest, the idea is that the combination of outputs of mutually exclusive nodes will outperform any individual models, which are then set the predicted outputs. So combining the output of multiple trees will get a better choice or better prediction uh, from it. Third algorithm used is logistic regression, which is another classification algorithm which is used where the response variable is categorical. The idea of logistic regression is to find a relationship between features and probability of particular outcome. Now let us go back to the code and see what we have done in the training phase. So we have imported the pipeline from scalar library. We have imported count vectorizer and these three algorithms: support vector machine, random forest classifier, and logistic regression. So first we have used the logistic regression algorithm. Here we have created a variable pipe underscore lr in which we have created a pipeline of two steps. So it will perform two steps automatically, or it does not need any further processing. So simultaneously these two processes will take place automatically. So first stage here is count vectorizer. So firstly the text will be converted into vector and the algorithm will be applied, which is logistic regression. After processing this pipeline, we'll fit our model, fit our train data into this model. After fitting the model, we will check the score by evaluating the model using our test dataset. So if we train our model using logistic regression algorithm, we get the score 0.620042 and so on. Similarly, we have trained our model using SVM, that is support vector machine algorithm. Here, similarly, pipeline is used for two steps count vectorization and applying the algorithm. Here, I have used radial biased kernel function for training the model, fitting the training data into model and predicting the scores, like what will be the score if we train our data using support vector machine. So using support vector machine, the score is 0.621, which is very close to logistic regression. In the third, we have similarly trained our model using random forest classifier and checked the score, which is 0.56, which is a bit lower than the other. So out of these three algorithms, you can choose the one which has a better score. Here there are two such algorithms. One is logistic regression and the second is support vector machine. Here I would like to use logistic regression. You can also use support vector machine here. Now the last step here is saving the model. So what is saving the model? Uh, After you train the model, you need to save it first, because machine learning models take hours and days to run. Now in this case our data is not too big, but when the data is large and contains many features, it will take hours and days to train the model. So if your machine goes off by any chance, you will lose your model and you will need to retrain it from scratch. So this will be a very hectic process. To avoid this, you need to save the model first. Pickle is a useful Python tool that allows you to save your model to minimize lengthy retraining and allow you to share, commit, and reload pre-trained machine learning models. Most data scientists working in ML will use Pickle or Jobly to save their ML model for future use. So Here I have used joblib library to save our model. Let us see what is the function of this library. Joblib is a Python library for running computationally intensive tasks in parallel. You can run multiple tasks parallelly using a joblib library. It provides a set of functions for performing operation in parallel on large datasets and for catching the results of computationally expensive functions. Joblib is especially used for machine learning models because it allows you to save the state of your computation and resume your work later on a different machine. So let us see the code. Here the joblib library is imported, which can be used to run multiple tasks parallelly. Next, we have created a file. We have opened that file in write binary mode. The name of the file given here is textemotion.pkl, which is pickle file. So we have created it and opened it in write binary mode. Now, in this file, we need to dump our model. So our model pipe underscore LR, that is our logistic regression model, which we have trained here, is dumped into the pipeline file. So joblib is used to move or dump the model into the file, and last the file is closed. After you close the library, close the file here, uh, a pickle file will be created automatically here. Here you can see a pickle file will be created, textemotion.pickle, textemotion.pickle. So now your model is saved. Now here comes the last part of the project, which is deploying the model. Out of all the steps in a machine learning life cycle, there is only one step that includes the user in it, which is model deployment. So model deployment includes deploying the saved model as a web app, GUI, or an OS-based application. Deploying models as a web app is one of the most famous and used methods that most developers use to test their models on real-life data. Now, you know that front-end is created using languages like HTML, CSS. You might have heard about it. But in Python, there are various libraries using which you can create web apps. So let us see a list of these libraries that will help you turn a model into a web app. First is Streamlit. Streamlit is an open source lightweight Python library that lets you create and share amazing data apps with fewer efforts and lines of code. It converts machine learning models into web apps in minutes. It offers many inbuilt functions that reduces the size of code and helps create web elements in such one line of code. Second is the Flask library. Flask is a micro web framework written in Python that provides useful tools and features that helps create customized web application easier. It's a backend framework, which means you need to use HTML, CSS, and JavaScript to make the front end of the website. So Flask here will require a bit of knowledge about the front end languages like HTML, CSS. Next is the Gradio. So Gradio provides the fastest way to demo your machine learning models with a user-friendly web interface. It can be embedded in Python notebooks or presented as a web page. It is easily integrated with most Python libraries, including TensorFlow, PyTorch, Scikit-learn, NLTK, Pandas, NumPy, etc. The last library here is Fast API. Fast API is one of the most popular web frameworks for building microservices using Python. Fast API is based on Pydantic and type hints to validate, serialize, and deserialize data and automatically auto-generate open API documents. It fully supports asynchronous programming and can run with UVCon and Unicon. Now let us see the deployment code. So I have used PyCharm to write my deployment code here. First, you need to create a project in PyCharm. So for creating the project, you need to click on the file, new project, and you need to just enter the project name and a project will be created here. Like here, my project name is text emotion detection. Under this project, we have two directories, data and model. So for creating directories, just right click on the project, new and directory. This will create a new directory. You can name it as you wish. So here I have two directories, data and model. In my data directory, I have my CSV file or the dataset which we have used for training our model. And in the model file, we have the pickle file which we have saved earlier. The third thing which we have used here is which we have included here is the a Python file which is app.py in which the deployment code is written. So for creating this Python file, similarly right click on the text emotion detection or project name, new and Python file. This will create a Python file. Name it as anything you wish. Here I have named it as app. Now let us step by step see what we have done. First we have imported Streamlit library. As I have said, I have used it to create the user interface or GUI for our model. So I have imported Streamlit library here. Next, pandas is imported, NumPy is imported. We have seen about this library earlier. The fourth library imported here is Altair. Now many of you might not have heard about this, but Altair library is a library for creating statistical visualization. It provides several features to perform data analysis while creating stunning visualization. So similar to Matplotlib, Seaborn, Altair is another visualization library used for creating visualization. Next, we have imported the joblib library. So joblib is used to run multiple functions parallel. Using joblib.load function, we have loaded our pickle file into this code or file. So using open in read binary format, we have loaded our text emotion pickle file. Next, I have created a dictionary in which you have key value pair as emotions and emojis depicting that emotions. Like for anger, I have used this emoji. For disgust, I have used this emoji. For fear, this. Similarly, for other emotions, uh, I have multiple emojis. Now let us jump to the main function first. So in the main function, we have written code for creating the user interface. So st is an alias of Streamlit. That means using st you can use the functions in Streamlit library. So st.title will give title to our web page. So as you have seen in the web page, text emotion detection is the title. Now st.subheader function gives the subheader for our web page, that is detect emotion in text. You can see here detect emotion in text. Now we have created a form. In this form we have taken raw text or the input text from user. So in this text area we'll take input from the user. I'll show you. So this is the text area. You can take input from the user, anything. So user can enter his text here. After entering the text, user needs to click the submit button. So submit button is created using the function st.form submit button, and it is labeled or named as submit. Next, if the user clicks on submit text or the submit button, it will automatically generate two columns. Now here, after clicking on submit button, you can see we have two columns. First column, second column. So we have written the code for creating these two columns. Next, we'll see what is predict emotion function. So whenever user inputs his text, the text will be given as an argument to predict emotion function. So what is predict emotion functions? Predict emotion functions takes raw text as an argument, and using the model, using the trained model, it will give us an emotion or emotion as an output or prediction. So for my text, I am okay, the prediction given here is neutral. So using this function, we can get emotion for a given text. Next is the probability function. Get prediction probability function will give us the probability of that emotion for a given text. So giving our input text as the parameter or argument to this function will the results will be the probability of that emotion. So here there is 0.51 probability that the text is neutral. Now let us see how to create the column or how to design the column. So in column 1, first original text is printed or displayed here. So using st.success, we will display original text in our web page, and below that text will display our raw text or the text inputted by our user. So here you can see the text or sentence I am okay is printed next to the original text. Similarly, prediction is displayed. In prediction, we have two parts. So first part will be the emotion and the emoji depicting the emotion, and second is confidence, which will give us the probability of that emotion. So for the code for this is written here. So from the emoji dictionary, emotion emoji dictionary, we'll get an emotion for our prediction. That, like for example, if our prediction or output is neutral, in the dictionary it will search an emoji for neutral emotion. So for neutral emotion, here you have this emoji. So this emoji will be used, and the output will be displayed in the format prediction, that is the emotion which is neutral, and emoji icon, which was the icon. This icon will be printed, and in the next line you will get the probability using the probability function. In the second column, we need to display a graph of this kind. So this graph will be a probability versus emotion graph, in which chances of each emotion for the text will be shown. Like our text has higher chances of being neutral. After that, it has chances of being in joy emotion. So you can see the column and by visually representing it. So how to represent it visually? The code given is here. So using this code, we have created a data frame in which probability and the class or emotion is used, and using these two columns we will plot a bar graph which will show the probability versus the emotion like this. Now I'll show you how to run the code. So first we need to run this app.py file. So click on the run button. Here automatically the process starts. Now you can see, to view this Streamlit app on browser, run it with the following command. So this command can be can be used to run this app on our browser. So you can directly paste this in your PowerShell or command prompt to open your app on a browser. Sometimes it doesn't work, so I'll show you how to run it using the command prompt. So in command prompt, you need to first go to the directory where our app.py file is. So our app.py file is in the C folder, in code folder, in text emotion. So I'll enter into these directories first in the code, then into the text emotion detection folder. Now we are in the text emotion detection folder. So in our text emotion detection folder, we have this app.py file. So here you can now write the command streamlit run app.py. Streamlit run app.py. File name .py. So hitting the enter button, it will automatically open the web page. Now you can enter any text here. For example, I am afraid of the dark. We all know that this sentence has the emotion of fear. Let us see what our model predicts. Hitting on the submit button, you'll get the following output. See, the original text is this. Prediction is fear, and the emojis of fear are given in front of it. Confidence, that is probability or chance of the sentence being in the fear category, is 0.9727. Here in the second part or second column, you can see the bar graph. You can see fear has the highest probability. That means our text has a higher chance of being in the fear category. So I hope you have enjoyed watching my video. All the data or code will be given in my GitHub. The GitHub link will be mentioned in the video description. So if you enjoyed watching it, please like the video. Thank you for watching.